Hi, hello. Today we want to go over how to write a sum of sines and cosines into a single sine and cosine, provided that the frequency or the wavelength of each term is the same. So let's get started. And so let's look at the kind of problem we're talking about. Let's say we're trying to figure out, you have a cosine omega t plus b sine omega t, and you wish to write this as a single sine or a single cosine. And to see what I mean is eventually we're going to do this problem right here. So let's go ahead and see what we could do. Now, the two formulas, depending on whether you want to write it as a single cosine or a single sine, it depends on which angle addition formula you like. There's one that says that if you have the cosine of a plus b, that's cosine a, cosine b, minus sine a, sine b. And then there's the one for sine, which is sine a, cosine. Oh, I screwed that up. I guess I could have done that, but I want to keep the same. Sine of a, cosine b, plus cosine a, sine b. So it really depends on which of these two you want to use and what your end result you want to be. Now, the first thing we want to do, because remember, this is what we want to convert, is you do the following. And it's sort of a clever thing. First of all, let's think about a right triangle with a side A and a side B. And an angle, let's just use this angle phi here. Now, and let's use this angle, use that angle there, gamma. Now, we know that if we use phi, we know that the cosine of phi is equal to b over the hypotenuse, which by the Pythagorean theorem is the square root of a squared plus b squared. And we also know that the sine of phi is going to be opposite over hypotenuse. Now, you might be asking, what does that have to do with this? Well, let's just try to put everything in terms of a cosine. So let's take this thing here and divide both terms by this, by what I call the hypotenuse term. Now, you might say, well, since I did that, I had to not change the expression. I had better multiply this by this. And by the way, this term here is going to turn out to be the amplitude. Now, let's try to fit this into this template here. Well, if I try to fit this into this template, what this means is that a over the hypotenuse term, right? The a over this hypotenuse term is going to be the cosine of gamma. So this thing here this will be the square root of a squared plus b squared This now is written as cosine of gamma, cosine of omega t, plus, that's now going to be the sine of gamma. Now, when we plug into this formula right here, notice there's a sign difference. So what I'm going to do is I'm going to use negative gamma. And by that, this turns out to be a single cosine of omega t minus gamma. The minus comes from the fact that we have a plus here instead of a minus. So this is going to be the amplitude. Notice this angle doesn't change. And this thing here is sometimes called the phase shift. And let's demonstrate this. Let's demonstrate this with this example that I have here. 3 sine plus 5 cosine. So let's say I have this example. And I better remember that 3 sine of 5x, okay? Plus, and I can't remember a thing, 5 cosine 5x. So now, let's just do this. This is a coefficient in front of here. 5 will be your A. 3 will be your B. The square root of A squared plus B squared is the square root of 34. So we now have this written as the square root of 34 cosine of 5x minus gamma. But let's remember what gamma is. This gamma, cosine of gamma, is A over that. Well, we also know that tangent of gamma is B over A. Okay. So gamma is, you know that the tangent of gamma is B over A. Or writing this way, and I'm going to use the arc things. Arc tangent of 3/5. And let's just take a look. Y equals square root 34 cosine 5x minus arctan 3 over 5. Oops. And we see that we get the identical part in this distance here, and we can maybe blow this up a little bit. I'll get rid of all this extraneous stuff. You don't need to see another thing of me. Let's just blow this up a little. This distance right there is the phase shift from here to there. Now let's do it the other way. Let's start now. Let's do this as a sine. So let's look this thing and write it as a single sine. Well, here's our triangle. I'm going to write the 3 here, the 5 here. The hypotenuse is still square root of 34. Now, with this angle, we know that the tangent of theta is now, of phi is 5/3. So what we have right here is we get the square root of 34 sine, and we're going to be using this. We're going to be, the sine is going to be that. sine of 5x plus arctangent of 5/3. So let's try that. Sine 5x plus arctangent of 5/3. And we see these graphs are identical because they are. And what we did in this case is what we did right here is this a part right here over a squared plus b squared or the square root of, that's going to be your sine of phi, and your b is going to be your cosine of phi. So that's the only difference. So hopefully this will be enough to get you through the quiz problem. So thanks for watching.